All right, so let's see what happens when we take a function's input and cut it by half, right? Cut it in half, and then it's going to take twice as much input to achieve the same output. Okay, so the same thing happens with the sine function. If we take the input to the sine function and cut it in half, we multiply it by a half, then it's going to take twice as much theta to give us the same output that sine would have otherwise. Okay, so here's a graph of the sine of theta and the sine of 1/2 theta. Okay, so where sine of theta normally cycles from 0 to 2 pi, so it has a period of 2 pi. Now, because we're going to require twice as much theta, because we're taking theta and then like halving it, we're turning down the volume of theta, so it's going to take twice as much theta to get the same output. And so we end up stretching. We get a horizontal stretch of the function. Okay, so you can also look at it the same way I did before. So our input is now 1/2 theta, and if we look at the sine of 1/2 theta, we know that when the input to sine is 0, you get 0, and when the input is 2 pi, you're going to be back at 0. Okay, so this is the input to sine. Okay, but our theta is just theta. So in order to, in order for 1/2 theta to be 0, theta has to be 0. But now in order for 1/2 theta to be 2 pi, I have to have a theta of 4 pi. Okay, so it takes twice as much theta to achieve the same output because I'm taking it and cutting it in half before I feed it into the sine function. All right, so let's take a look at these two graphs. So the normal sine function has a midline of 0. Sine of 1/2 theta still has a midline of 0. Amplitude is still 1. But the period of sine of theta is 2 pi. The period of sine of 1/2 theta has to be twice that. Okay, so 4 pi. All right, so let's take a look at example 2. What happens, what is the period of sine of 1/3 theta? Okay, so again, I can think of 1/3 theta as the input to the sine function. Okay, and so this is the sine of 1/3 theta. Okay, so I know that when the input to the sine function is 0, sine of theta, or the sine of 0 is 0. When the input to the sine function is 2 pi, the output is again 0. That's one cycle. But now what does theta have to be? Right? So to get 0 theta, for 1/3 theta to be 0, theta has to be 0. But in order to get 1/3 theta equal to 2 pi, now I have to feed in 6 pi, right? Theta has to be 6 pi in order for the input to sine to be 2 pi, right? Because it takes 3 times as much theta to get the same output. So in this case, we're going to have a period is 6 pi, right? So one cycle is not going to happen until we get to 6 pi. And so if you were going to graph that, again, here's 6 pi. I'm just going to, it's, just same thing. I'm just going to break it into 4 equal parts, right? So this is going to be 3 pi over 2, and this is going to be, what is this, 9 pi over 2, right? Halfway in between there. And it's just going to look like a normal sine function. It just takes longer to complete a cycle, right? So it's going to look something like this, where this goes between 1 and -1. Okay. All right. So here's kind of the result, is that the period, if we have, sine of b, some constant times theta, or cosine of b theta, then the period is 2 pi over b. Okay, so this is probably something you want to remember. All right, that you can find the period by taking 2 pi over b. All right, so I will meet you in the next video.